recombination of electron-hole pair. Electron-hole pair are dissolved when an electric field makes the electron to fall from valence band to the conduction band, and it combines with the hole therein, thus releasing a photon on combination. This all happens spontaneously, thus the probability that the electron and hole will recombine is constant in time. Thus, this recombination of excess minority carrier for a p-type semiconductor for a recombination lifetime tau n is equals to 1 upon p naught. Concentration would be del n e to the power t by Tn, where tau n is the lifetime of the electron. Indirect recombination. In indirect recombination, mostly in group 4, which takes place with the release of heat energy, not light energy as in case of direct recombination, heat energy rather than a photon with electron setting from an intermediate state before falling to the valence shell. The electron in this case moves to an intermediate shell or state, and when it gets a empty valence gap, it falls into it, and thus a recombination takes place. The two-step procedure that occur is first, an electron from the intermediate state falls into the valence band, and to take that place, an electron from conduction band is transmitted to the intermediate state. The conductivity of the sample for semiconductor is Qnt mu n plus P of mu P. Diffusion of carrier. Diffusion, as its literal meaning says, that when excess charge carrier moves from a region of higher concentration to the region of lower concentration. The rate of electron motion can be used in detecting the diffusion coefficient of electron, dn or dt. The net motion of electron due to diffusion is in the decreasing of electron concentration or hole concentration. Qn is equals to minus of dnx over dx, and Qp is equals to diffusion coefficient into the differentiation of hole concentration. The diffusion current crossing a unit area in the particle flux density multiplies by the carrier charge, where the diffusion current density is equals to Q into diffusion coefficient into concentration, into change of concentration of electrons. And you have to keep in point then diffusion current density of proton or holes is negative, and diffusion current density of electrons is positive. Now the diffusion and the drift current. On application of electric field, the current gradient will have drift and diffusion current. Diffusion current is because of the minority carriers, and drift current is the major charge current, and diffusion current, both are actually the major charge current. At equilibrium, no net current flow in a semiconductor. Thus, any fluctuation which would begin a diffusion current also sets up an electric field which redistributes carriers by drift. From Einstein relation, we can say that diffusion coefficient upon the mobility of each charge carrier is equals to kT by Q, which is 0.025 volts or 26 millivolts. This is an important relation. Keep this relation in mind, as it's often asked, that D is equals to mu of Vt. Okay, at last the